Yep, so I'll just give you about 1 more minute, maybe 2 more minutes to finish both of those up. Uh-huh.
Divide by 7. If I do that on the next step, do I do that?
That can be just like simplified.
Well, like divide by 7, it would be. Would it be like when I subtract 2? Would I just put the answer of what that is down here?
You could say this is like simplify, and then this is. But remember, it has to be like what property.
Like, so if I did. Oh, so like, so subtract 2, but I put the answer for that down here.
Yeah, we'll do them together. You'll see. All right, so let's go ahead and look at the board. Let's look at the first one, okay? So the first one, what should my reason be? Yeah, given, okay? That's always going to be our very first reason, okay? We write whatever we are given, okay? Whatever problem we are given, we just write that same exact thing down for our first statement and our reasons given, okay? What can be one of my first steps? Because there's a couple different ways we can approach this. Subtraction property, what are we subtracting? Yeah, we can subtract the 2 first, okay? So if I just showed and subtracted the 2, I'm just going to put this here. Okay, I'm subtracting 2 on both sides. All right. I can show that step and say subtraction property and then put my answer on the third one and then put simplify. Or if I just show it kind of right here, if you put it to the side, next thing you put is just 3x equals 21 minus 4x. Then we can just put subtraction property here because we already did that. It can just look just like that. Okay, if you did simplify, then that's totally fine as well. Okay, now what about our next step right here? What do we need to do? Yeah. Yeah, we need to add 4x on both sides. So when we do that, it gives us 7x equals 21. All right, and what property is that? Addition. Perfect. And then what do we do for our last step? Divide what? Yeah, do we divide 7 so we get x equals what? 3. And what property we just use? Division. Perfect. Okay, so it should look just like that. Or if you had the simplifying, that's fine as well, but you need to at least have a subtraction, addition, and division. Okay, maybe you added the 4x first. So if you had addition property first, that's totally fine. But as long as you get x equals 3 and you divide on that last one. Okay, any questions on that first one? All right, let's look at the next one. Okay, what's my first reason going to be? What's the first reason going to be? Given. Perfect. All right, then what do I need to do? What can I do for my next step? Yeah. Yeah, we can add the 17 over. Okay, when we add the 17 over, we can get 2p. Okay, 17 plus 9, what is that going to, or sorry, 17 plus negative 9, what is that? Plus 8 equals 10p. Okay, and we just did the addition property. Okay, what about my next step? What do I have to do? Yeah. Yeah, add the negative 2p, so that gives me 8 equals 12p. All right, and what property is that? Again, we added, so it's going to be addition property. All right, now what? Yeah, we need to divide by 12, okay? All right, when you do this, we can just leave our answer as a fraction. Okay, if you put it as a decimal, that's fine as well. Okay, but as a fraction simplified, what would our answer be? 2/3. Okay, we can just put P equals 2/3. All right, what property is that? Division. Oops. There we go. Okay, is this ringing a bell from last week? All right. Just make sure you're remembering those properties. Okay, the only ones we used right there were addition, okay, subtraction, and division. All right. But just make sure you know those other properties like transitive, distributive, and all of those extra properties. Okay. So that's the algebraic proof. So now we're going to kind of go more into the geometric and work with angles. So let's go ahead and look at these slides. Okay, so we're going to have geometric proofs. All right, and that's what today's section is going to be about. All right, and that topic will still be on top. All right, this is just kind of explaining the proof process, which we've already kind of talked about, so you don't have to write this down. But just know we're still using that logic. Okay, we still have the hypothesis, the conclusion. We're just kind of going a deeper dive into that. Okay, so we can use symbols, abbreviations that are clear enough to anyone who reads the proof will understand them. Okay, so let's go ahead and look at an example. Okay, this is going to be 2.8. It just says 2.6 on top because we added the slope. I'm sorry. It's going to be 2.8. I know it says 2.6, but we added some stuff before. So go ahead, write this down on the top, draw two angles out, all right, and then just put A and B are supplementary, okay, and the measure of angle A equals 45 degrees. All right. Okay, so on this one, all right, we're given that A and B are supplementary. Okay, we're going to be solving for B because we are given whatever our angle A is already. Okay, since we know it's supplementary and since we know what angle A is, okay, you should already know how to solve B. Okay, but we have to explain that in steps on how we know how to solve for B. Okay, so what is my first statement going to be? Who thinks they know what the first statement? Yeah. And what do you think the reason is going to be for that? Yeah, given. Okay, so it look just like this. So in your statements, if you write it out like this, now you have a statements column and a reasons column. All right, and your statements is going to be angle A and angle B are supplementary. And if you just put our like supplementary, okay, SUPP, and you know that means supplementary, that's fine. And then you can just put the measure of angle A equals 45 degrees, okay? We're going to say that is given. Yeah.
Wait, so the measurement of angle A is 45?
Yes. Okay. So we know our given. Okay. Now, when you are looking at this, and we need to explain it to someone, okay, we need to explain like what the word supplementary means. Okay. So what does supplementary mean? Yeah. Yeah, so we know that it has to be two angles that add up to equal 180. Okay, so when we do that, all right, our next step is going to say angle A plus angle B, so the measure of those angles equals 180 degrees. And we know that because that's just the definition of supplementary angles. Okay, we're just explaining that definition. Okay, so I'm just going to put that as my second step. Okay, so now that we explained what supplementary means, okay, now we can kind of start that process of solving for B. Okay, so since we already know that A equals 45 degrees, okay, we're going to use that, all right, and we're just going to substitute it into the problem. Okay, because we already have the measure of angle A plus the measure of angle B equals 180, so we're just going to substitute that value of A and put that into the equation. Okay, so that's going to be our third step. Okay, we're just substituting that value. All right, and that's just going to be substitution property. All right, so we're using, like what it says in the blue, we're using the steps 1 and 2. All right, for our step 3. So substitution. I'm just going to put a T here. Okay, perfect. What do we think our next step is going to be? Yeah, we just need to subtract the 45 minus 180 to get our measure of angle B. Okay, so you should just do, if you already subtracted, okay, you should get the measure of angle B equals 135 degrees. Okay, and that's going to be subtraction property. Okay, make sure you don't just put SUB. All right, and you've got to distinguish the two between subtraction and substitution. Okay, so you can't just put sub property. You got to make sure you add that S or add that T to explain the difference between the two. Okay, do we have any questions about this? All right, yeah. That's just substitution property. Like we learned that it was like of equality. We don't need to worry about that. You just know, just use subtraction property. Okay, you don't need the of equals. Just know what that stands for. Okay. All right. Let's look at one that include midpoints. Okay. So what it's already going to give us is it's going to give us all of our statements. So go ahead and write this down. All right, and those are all your statements. We have to come up with the reasons. Okay, so I'm going to write them on the board as well. But go ahead and get that written down in your 2-column proof. Okay, and we're going to figure out those reasons. Okay, if you look at this one, all right, it might be a little different from the last one. And we're going to be using some different properties as well. Okay, first thing that it says is B is the midpoint of AC. Okay, and we got to come up with our reason for this one. All right, how do we know B is the midpoint of AC? Yeah, that's our given. Okay, it's given above. Okay, so that is what our reason is going to be. All right, that's just given information. Okay, perfect. Now we have AB is congruent to BC. Okay, so if we look at the image there, all right, it's telling us that AB, okay, is congruent to BC. All right, how do we know that? Yeah. So B is the midpoint of AC. So we're like explaining what the midpoint is. So what do we think the reason's going to be? If we're explaining it. Yeah. Yep, just definition of midpoint. Okay, that's your second reason. All right. So even though we know what midpoint means, all right, we got to explain it, what that means. Okay? So since B is the midpoint of AC, we know AB is congruent to BC. This is the definition of a midpoint. Perfect. All right, next we have AB is congruent to EF. How do we know that? Yeah. Yeah, this one, it's given, okay? So this one, it doesn't have both givens on top, okay? So it puts it here, all right? If you put them both on top, that is totally fine. But this one separates it to kind of help us for that next step, which is going to be that last step. So the last step says BC is congruent to EF. All right, who thinks they know what our reason is going to be for this? Not symmetric. Uh-huh. So what's our reason? Transitive property. Perfect. So this would be an example of transitive property. Okay. Perfect. You're on the right track. I knew what you were talking about. Okay, do we have any questions about this one? Okay. We see where we got all that stuff. Okay. Now, we're going to have some theorems as well. Okay. You don't have to really worry about writing this down. But just know this is any statement that you can prove. Once you have proven a theorem, okay, you can use it as a reason in later proofs. All right. So with theorems, okay, maybe we might have the linear pair theorem. You don't have to really worry about this either. So just know, okay, if two angles form a linear pair, then they are supplementary. Okay. We pretty much already know that, but we do have to explain that before. Okay, so if you're given that two angles are a linear pair, you have to explain, okay, if they're a linear pair, then they're supplementary. So that would be an example when you would use the linear pair theorem. Okay, or congruent supplements theorem. Okay, if two angles are supplementary to the same angle, then the two angles are congruent. Okay, so it's saying if angle 1 and angle 2 are supplementary, then angle 2 and angle 3 are supplementary, then angle 1 is congruent to angle 3. Okay, so that would be the congruent supplement theorem. Okay, we've been talking about a two-column proof. Okay, let's look at this one. All right, so it says fill in the blanks to complete the two-column proof. So go ahead and write your two-column proof, and we just got to figure out what the reason for number 2 is. So go ahead and write that out, and then see if you can figure out what that reason is going to be. Yep, just go ahead and write the whole thing out. What you put? Interesting. Okay. See, we got that. Okay, so with most of our proofs, okay, it's going to look like this, where it's going to say given, and then it's going to say proof, okay? What's nice is on these proofs, all right, it already tells us what our given is, okay, that's going to be our first statement, that's going to be our first reason, okay? 2 easy points there. Well, the nice thing is when it tells us what to prove, okay, this statement, what it tells us to prove is going to be our last statement. So anytime it says prove something, that's your very last statement. Okay, so if it's a 4-step proof, okay, you should already automatically know the first one and the last one because it tells you what to prove. Okay, so make sure you know that. All right. On this one, okay, we're given xy, all right? And we need to prove that xy is congruent to xy, okay? So we write our given, all right? We put that in the first statement. We put that as the first reason. All right, next one, it says that xy is equal to xy, okay? Who thinks they know the reason for this? What do you think, Jordan? Perfect. It's going to be reflexive property, all right? So that's our reason. All right, and then on the last one, we put what we have to prove. So xy is congruent to xy. All right, and that's because of the definition of congruent segments. Okay, so since they are equal here, all right, we have to change that it's equal to congruent. All right, that would just be definition congruent segments because it tells us to prove that they're congruent. So if you have equal all the way down and it says prove congruent, you eventually have to switch that equal to congruent. So just make sure you know that. All right, this next one's going to be a little small, so I'll zoom in a second. But go ahead, write your given, your prove. All right, if you want to draw those angles out as well, go ahead and draw those angles. And then I will zoom in on the box in a second. But go ahead and get that down. All right, and then if you notice, okay, it is a 6-step proof. Okay, so there's going to be 6 statements, 6 reasons. All right, and I hope you're able to at least get 2 of them, 2 of the letters that you have to find. Okay, go ahead and write that top part out, and then I will zoom in a second. So just make sure you get that written down. All right, it will go back to the screen. If you don't get all of that, just make sure you leave room. Okay, but here is the box, all right, to help you out. So it's a little more zoomed in. So hopefully that can help you out a little bit. All right, and then we will go back to that original slide to go over what those letters are going to be. Don't do that. Don't do that. That's probably the teacher doing this. Okay. Say that again, Tanner. Whatever you think. We'll go over it. All right, so go ahead and get all that written down. See if you can figure out what to do. All right, now try to figure them out. If you don't get A and D, I'll be disappointed. Oh, no, no.
Yeah, I was right. You see how I did it?
Yeah.
It's not funny.
All right, so get that all written down. All right, I'll give you like 1 more minute to figure it out. I'm going to go back to the original slide if you did not finish that given in the prove. Okay, so here's that. All right, look at your neighbor if you need one of those last steps and didn't get that written down. If you have a neighbor. Yeah. It's just, that's like an angles. It's an angle with an S. So it's just saying angles. So it's saying definition of congruent angles. Not quite. Okay, let's go ahead and talk about this, okay? So A, okay, we got to figure out what we put as our first statement, all right? I really hope everyone got this one, but what do we think it's going to be? Yeah, Maddie? Perfect, we just put what we're given, okay? So it should look something just like that, all right? Angle 1 and angle 2 are supplementary, or in angle 2 and angle 3 are supplementary. Okay, perfect. If you look at the next statement, okay, it says the measure of angle 1 plus the measure of angle 2 equals 180. Measure of angle 2 plus the measure of angle 3 equals 180. All right, and that's the definition of supplementary angles. So we're just explaining what supplementary means. All right. Now we got to look at 3. Okay, we got to figure out what our third statement is. And our reason is the substitution property. Okay, so we got to use something above, and we're just substituting. Anyone want to try an idea of what they got? Or anyone think they nailed it? Okay. If the measure of angle 1 plus the measure of angle 2 equals 180, okay, measure of angle 2 plus the measure of angle 3 equals 180, then what else can we say? What? Pretty much, okay? We can say the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. Okay, perfect. So that's just substituting, okay? If they both equal 180, then we can just equal them to each other. For step 3, for those two angles, what? It's saying them added together equal each other, but the measure of angle 2 is the same as itself. Okay, so that's our third step. Fourth step, it says measure of angle 2 equals the measure of angle 2. Okay, because that's reflexive property, so we're explaining, okay, the measure equals itself. All right, so those equal. Then it says measure of angle 1 equals the measure of angle 3. Okay, who thinks they know what this step is going to be? What do we think? This one's a little tricky. Yeah. What do you think, Julian? No? No? It's a little tricky. Okay, it's going to be subtraction property. You subtract the 2's out. So we can say measure of angle 2 equals itself because it's reflexive. If we look back at this equation right here and we subtract the measure of angle 2 out, then it leaves us with measure of angle 1 equals measure of angle 3. Okay, so it's just subtracting the measure of angle 2 out of that equation. Okay, does that make sense? All right, hopefully we all got D, because what's D going to be? It's what we're proving, okay? So angle 1 is congruent to angle 3. All right, and that's the definition of congruent angles. Okay, perfect. All right, do we have any questions about this one? Okay. All right, that was with the congruent supplements theorem. All right, if you just look at this, we could say the same thing about right angles. Okay, so if two angles are right angles, they're congruent. All right, and then we can do the same thing with complementary angles. Okay, draw it on your own. All right, we'll do one last one. Write this down. Okay, don't worry about the plan. All right, write your given down, write your proof down, and then I will show you the box on the next slide. All right, and I will show you what we're given. Just write this down, Adam. Write that given, write that proof down. All right, and then I will tell you, I will give you the box of what we have to figure out. So what letters? Yeah. No, don't worry about the plan. Okay. Get that written down. If you want to draw the angles, maybe that helps you out a little bit. Draw them. Okay, and then write your statements and reasons column. All right, then put your pencil down so I know you're done. All right. Okay, here we go. We got to figure it all on our own. We don't say, oh, shoot. We say, woo. It's 10 points. We're going to get right here. Woo. No, don't say that word. Yeah. No brain rot in this class. Okay. All right, so what do we think our first statement is going to be? Say it louder. Yeah. Okay, we're going to put our given. All right, so our given, all right, we have angle 1 and angle 2 are supplementary. All right, and we're going to put our givens together. Angle 1 is congruent to angle 3. And what do we think our reason is going to be? Given. Good job. I'm glad you know that. Okay. Who thinks they know what our next step is going to be? Is there any words up there that we need to explain? Yeah. Perfect. The measure of angle 1 plus the measure of angle 2 equal 180 degrees. Okay. And this is going to be what? Yep, the definition of supplementary angles. Perfect. There we go. Okay. We used one of our givens. Let's use the other given. Okay? Because what do we eventually have to prove? Yeah, we got to explain that 2 and 3 are supplementary. Okay? Now, our next step, what we have to do, okay, is we are going to say the measure of angle 1 equals the measure of angle 3. All right, who thinks they know what this reason is going to be? Yeah. No. Yeah. No, it's not given. What do we change from the first statement to the third statement? Yeah. No, not quite. Yeah. It's going to be definition of congruent angles. Okay? Because we're just changing from congruent to equals. Okay, so anytime it's congruent, okay, we can say that they're equal, because eventually we have to prove that they're angles. So this is just definition of congruent angles. Okay? We just have to change that congruent to equals. Okay? Because do you remember, what does congruent mean? What do we say the difference between congruent and equals? You should have written in your notes this in your notes last week. What do we say congruent does, and what do we say angles or equals does? Yeah, numbers are equal and figures are congruent. Okay, so we have to say 2 angles. Those are going to be are supplementary, so we're saying the figures are congruent. Okay, or no, so we have to say they're equal. Okay, because numbers. Okay, supplementary is going to be 180. So that's why you have to change from congruent to equal. Because we're saying it's supplementary, so we have to. We're gonna with our next step. Okay. Our next step, we're going to say the measure of angle 3 plus the measure of angle 2 equals 180. Okay? Who thinks they have an idea of what's the reason, why is our reason for this? Perfect. Substitution property. Okay? We're just substituting. We have this, our second statement is angle 1 plus angle 2 equals 180. We said angle 1 equals angle 3 here, so we can just substitute angle 1 or angle 3 for angle 1. Okay? Finally, we have to put our last statement, and what's our last statement going to be? The prove. And what is the prove? Yeah, angle 3 and angle 2 are supplementary. And what do we think our reason's going to be for this one? Yeah. Nope. We can't, given, can't be last. Yeah. It's going to be definition of supplementary angles. Okay? I know we already did it earlier, but this time we have two different angles. Okay? It's kind of the reverse of what we did is we went from they are supplementary to explaining that it's added together to equal 180. Well, if we already have that these two equal 180 and we have to prove that they're supplementary, then we're going to just do definition of supplementary angles again. It's just that like reverse. Okay? Do we see what we did there? Okay. We're going to do more examples like this tomorrow. Okay? Because the more you do, the better you'll get at them. Okay, but we're going to have some of these on our quiz on Wednesday. All right? You have no homework. Okay? We'll do more examples together tomorrow.